lab says that acceleration is the change in velocity per second, which means we need to change the velocity every second. How do we change the velocity every second? Well, right here is where I ask you to write the code. If I want to just change the velocity every second, why don't I just take this velocity and add like 1 to it every frame? That's it. That's all you need. If you just add to the velocity every frame, this will make it so that this ball will drop every time through this loop. So I'm oversimplifying it. So you can see here how it doesn't quite make it up, but it's dropping. So why does this work? Remember, if I remove this line, my ball is not moving at all. This is really easy to see when your velocity is 0 to start. So if I move this thing to be in the middle of the screen, this is my velocity. My velocity is 0 right now on the ball. If I add to the velocity every frame, this will make the ball drop. So if I... Okay. Why does this work? Well, I'm just going to print out the velocity. Velocity is okay. I'm going to print it out without any gravity to start. 0. That's not a very good way to print that out. The velocity is 0. Obviously, it's not moving, right? If I add to the velocity every frame, the velocity is going to start going up. But watch, it's going to start at a small number, and it's going to start going up and up and up. It started at 0, and it's going faster and faster. That's the speed of the ball is going faster and faster. And every time it bounces, it flips. And when it gets to the peak of the ball, when it gets to the peak of the basically the top of the apex here, it hits 0. So look, the velocity is negative 25, going down all the way to 0, and then it starts going up again. That is all it takes for acceleration. Now, I asked you to do this to set it up so that your gravity is somewhere between 500 to 1,000 pixels per second. If I want it to be 1,000 pixels per second, I just take this and I multiply it by delta time as seconds. Okay? This right here is how you get it to drop at 1,000 pixels per second. Now we have a bouncing ball, right? So look at the velocity over here on the left. It looks like it's increasing by 1,000 per second. Like if you count it to 1 second, it's basically going up 1,000 per second, which is different from the position of the ball. All right, so let me show you guys how this works. I'm going to just draw a graph because I think this is the only way to really reasonably show this. So if I just draw this graph, and I'm going to represent time here in spreadsheet form. So I'm going to represent like 20 seconds worth of data. So this right here on the left is going to represent time. This is going to represent acceleration. Acceleration never changes. Acceleration is a constant that gravity is 9.8 meters per second squared. No matter where you are, no matter what time period you're in, This is what the acceleration is. This stays the same. This velocity starts at 0. And then it's going to be equal to what it previously was plus the acceleration here. So I'm going to say d3. And the velocity here is going to increase. This is how fast the ball is moving, right? The velocity goes increase every second. The position here is based on the velocity. So how fast, if this position starts at 0, it's going to be equal to the previous position plus the velocity here. So is this going to be 1,500? What's this going to be? 3,000? 5,000? That looks like it's increasing way faster than the velocity, right? It ends up at 85,500. So if we chart this time based on let us do just going to chart this here. So this is our position over time, right? Look, our position is curving upwards. But if I add velocity into here, look at our velocity over time. You see how it's basically a straight line here? If I extend this out even more, so our position changes that much faster. Our velocity is going up while our acceleration stays the same. So look at this curve here, and it's going upwards. If I just show you guys velocity and time, this is the chart of how the velocity is changing. Notice it's an exact straight line, but the position is changing as a curve, right? This is the relationship between the two. Your position is going faster and faster and faster. In fact, if you were to fall infinitely long without hitting terminal velocity, your speed would forever be increasing, which means your position would just be going faster and faster. And here, our acceleration is the same. Our acceleration has remained the same, which is why when we go here and we increase our velocity by 1,000, which is the constant acceleration we have, this goes up linearly while our position goes up exponentially. Okay? This right here, this is basically our position. And that is why the ball looks like it's bouncing. It slows down near the top and then speeds up. If we wanted to make this something really small, like low gravity style, it's falling and it's going faster and faster. Okay. All right. Questions? Okay, so let's change it so that bounce, every time it bounces, it cuts in half. So I'm going to start off by having this ball move slightly to the right and bounce. So again, if I make the ball move to the right and bounce, it'll bounce off all four corners, and now it looks like a bouncing ball. Oh. Every time through this if statement, though, this is the if statement that says, hey, I bounced off the bottom of the ground. If I multiply this by 0.5 instead of multiplying by -1 here, now every time it bounces off the ground, it'll cut in half. So watch this again. Bounces and it cuts in half. This number here represents how much of the previous velocity we keep whenever we bounce. So if I change this to be 0.8, it'll bounce a little higher. It'll still eventually slow down. And then it'll settle in and then start rolling around. Okay? All right, so the final part of the lab was that when you press spacebar, it makes the ball jump upwards. This is also very straightforward. We already have a spacebar here for charging. I'm going to get rid of all this charging stuff here. Delete this. So whenever I hit spacebar, all I want to do is say, hey, velocity.y plus equals, or minus equal, I don't know, 600. Let's give it a little bit of a boost. I'm subtracting 600 from the velocity every time I press spacebar. So I can make it jump up, like that. If it's already on the way down, it doesn't jump up very far. And every time I hit spacebar, I'm basically doing double jump. Genji. It's Genji. If I press and hold it, it'll just... Okay. And eventually it'll slow down. And that's it for that lab. All right.